Well, good morning or good afternoon, depending upon where you're calling in from. My name is David Huffman. I'm with Storage Software, and this is disaster recovery of Red Hat, both physical and virtual systems. Without further ado, let's go ahead and get started. Okay, so who are Storix? Well, we've been around actually since 1999. We're the trusted expert in Linux and Unix backup and disaster recovery solutions. You might recognize some logos of our customers who utilize our software. And today we're going to be talking specifically about backing up and recovering Red Hat systems. But kind of to clarify here, we're really talking about Red Hat and Red Hat derivatives. So if you also have CentOS, or if you're using Oracle Enterprise Linux, which is based upon Red Hat Enterprise Linux, then it will include that as well. And so we also support Red Hat Enterprise Linux version 4 through 8, which is pretty broad. So I know 4 is definitely end of life according to Red Hat, but yet we still support that all the way up to the latest 8.1 that recently just came out. So for disaster recovery planning, I'm not going to read all this text, but I want to kind of highlight two different metrics that a lot of people you might hear bounced around. One of them is your maximum tolerable downtime, or your MTD, and that's how long your systems, your data center, can be down before the business is critically impacted. And then your recovery time objective, or RTO. That's kind of a more popular one most people have heard of. The RTO is how long does it take to get that server back online. And so essentially you add up all your RTOs and hopefully it meets your maximum tolerable downtime. Now, one way to reduce that RTO is backing up not only the data that's on those systems, but also backing up the operating system as well. Because if you have to go in and reinstall the operating system first before restoring your data, that can be really time consuming and prone to mistakes. Now, I want to preface by saying that there are a lot of great provisioning tools out there. A lot of people can provision out their systems, in a number of minutes. So we're really not talking about provisioning out a golden image, so to speak. We're talking about getting the system back exactly the way it was just prior to the failure. And the reason why I bring that up is because as a system goes into production, a delta starts getting created because you do security patches, you do updates, you install third-party software, you update that software, you've done some performance tuning, all the things that have been done to that system since it actually went into production. And so that's the part typically that's the time-consuming part, not just installing the OS, but actually installing the OS and then putting it back exactly the way it was. And so that's the part that's not only time-consuming, but also prone to mistakes because you may not be aware of everything that's been done to that system. In fact, we talk to sysadmins oftentimes where they've inherited these systems. They may not be aware of what's been done, or they basically purchased a turnkey solution where they had the database and everything pre-installed, and so they may not know what has been done to the system to make the database run properly. So why risk it? Why not just back up the entire operating system with all those changes in place as well as your data? Now, the Unix world has known about this for a long time. Solaris had Flash Archive, at least they used to. HPUX has Ignite, and AIX has Makes Us Be. But what about for Linux? Okay, I kind of put that up there for comic relief, but what does Red Hat actually say about this? Well, if the installation process is relatively easy, and if the application of bug fixes and customizations are well documented and easily reproducible, reinstalling the operating system may be a viable option. Well, again, in a perfect world, sure, you've got everything documented, you have all of your patches in a repository somewhere off-site, in case you need for off-site recovery. You'll have that all available, and you know every single time somebody's touched that system, right? Well, in a more perfect world, sure, but I think in reality, things have been done to those systems. You have multiple sysadmins maybe working on the environment, and so you may not be aware of everything that's been done. And so to try to replicate all of that and hope that the system comes back up properly in a short period of time, well, that can be problematic. So this is where our software comes into play, Storix System Backup Administrator, or SBAdmin for short. Now, first and foremost, we're a backup product. So we back up all of your data, but we also back up the operating system as well so that you have the ability to do a full system disaster recovery. Now, we have our own process to do this. It's called adaptable system recovery, and we'll talk a bit about that in a minute. The software is centrally managed from one system. It's very scalable. We'll talk a little bit about that. And then when you're writing your backups, you either write them to local or remote media, and we even have capabilities for off-site vaulting. Now, in today's demo, we're going to be really highlighting backing up and recovery of a Red Hat system, but we also do the same thing for other versions of Linux, whether it be Debian or SUSE. Linux on Intel versus Linux on Power, as well as AIX and Solaris. So if you have those Unix systems in play, what you see today will also work for those systems. We also have optional features such as our AS encryption, which is at military grade. And then we also integrate with Tivoli Storage Manager or Spectrum Protect. And then as far as managing the software, it's not just command line. You have a graphical user interface. We have a web-based interface. But as most sysadmins are comfortable with the command line, you can do most everything from there as well. So let's talk briefly about this Adaptable System Recovery Process, or ASR. Now, when most people think about doing a backup of the entire system, oftentimes they use the term image-based backup or disk image. I need a disk image of this system, or I need an image of this system. And our process is not image-based. Our process is file-based, and there's a lot of benefit to that. Now, I'm going to use this analogy of a brick, and thinking that as your disk image. So think of, because really all a disk image is DDing off the contents of the drive. So if you've got a terabyte drive, you just DD'd it all off onto this giant, binary file here. And with that brick of data, you don't have the flexibility of going in and saying, you know what, I just need to get a couple of directories out of that backup. No, it's all encompassing. There's nothing you can do to get in there and get what you need out of it. On the flip side of that, what if there's data that you don't want to back up out of that terabyte drive? Maybe you just want the operating system portion of it. Well, again, you don't have that flexibility with a disk image because there's no intelligence built into it. There's no, it doesn't know what's actually even on there. And so that's where a file-based backup approach makes a lot of difference, and there's a lot of benefit there because, and also when it comes time to recover the system, guess what? You're going to have to put it back onto the exact same disk geometry, same hardware as you had before. Because remember, inside of that brick, it's expecting to see particular hardware, it's expecting particular disks and disk geometry and so forth. So you really are very, very limited when it comes to recovery as to where you can put it. Now, our process being file-based is much more fluid. And so at the time of recovery, we can go in and restore the system to dissimilar hardware, dissimilar storage, and because it is file-based, if you need to go in and restore an individual file or directory, you can do that. Now, most systems nowadays, or a lot of systems nowadays, are all virtualized. So you might be saying, well, I've got snapshots for those, so I'll just use snapshots for my VMs. Well, snapshots are, again, just disk images. In fact, your virtual machine disk is really nothing more than a file pretending to be a disk, a big binary file pretending to be a disk. And so with that, though, with virtual machines comes kind of some different problems. So let's kind of break down, with a virtual machine, you've got your physical hardware, you've got your hypervisor on top of it, and then you've got all your guest OSs. Now, if we take one of these guest OSs and break it down, you've got your operating system, your configuration information, applications, got your user data, and then you've got your empty space. Now, if you're creating a snapshot of that, you're creating a snapshot of the entire thing. And if so, you have to take that off-site. Remember, you're having to take the entire thing off-site. But what if, and also creating these snapshots can take time depending upon the amount of data. But what if you really only care about the operating system part because you might be backing up the data portion using some other product? Maybe, it's a big database and you're using RMAN, for Oracle to be backing that up. So you don't really want this product, your backup product or your snapshots really capturing all that data because then it's just a waste of space when really you're going to be picking that up from some other backup product. So, but again, with snapshots, you don't have that flexibility to go in and say, you know what, I only want this part of it. And so that's where our file-based process comes into play, where you can selectively choose to say, you know what, I only want to back up the operating system configuration files and applications. And I want to exclude all that user data. And I definitely don't want to pick up any empty space, which again, you have to get with a snapshot. So to kind of recap here a little bit, let's say at your production site, you've got HP servers, and you show up at the recovery site, maybe you've contracted with SunGard or another provider. Uh-oh, they've got Dell servers. Well, not a problem. Again, with our product, you can go from dissimilar hardware. You can even go physical to virtual. So let's say you've got some production systems that are physical, and you get to the recovery site, maybe for a temporary usage, you wouldn't maybe for a long term, because there's probably a reason why it's on physical hardware. But if you wanted to for the short term, you could always restore that into a virtual machine. Now, we have a lot of customers who will actually use our product as a SysAdmin tool because maybe they've got legacy systems on physical hardware. They want to migrate that over into virtual machines. And depending upon how complex the system is, it's actually much easier to do that with our software. Also, virtual to virtual. So if your production site, you're running, let's say, VMware, but you get to the recovery site and, maybe you don't want to have a second license for VMware for all those instances. You want to use an open source based solution like KVM. And so you can back up all these VMware systems and restore them into KVM or any other open source, let's say, virtualization. Now, how does the software scale? So let's kind of talk a little bit about how it's laid out. So it is centralized backup management, which means from one pane of glass, you get to manage all of the backups. Now, most people are familiar with this type of scenario where you have a backup server and all of your clients are backing up to the backup server. Now, for smaller environments, this makes a lot of sense. But once you start growing into hundreds, maybe even thousands of systems, this doesn't work very well. We do have customers who have thousands of clients that are being backed up. This is not what they do. What we have done is we said, you know what? You still want the simplicity of managing everything from a single pane of glass, but you don't want to have to write all of your backups to one central point of failure. So with Storix, we've actually separated out. Now, we call this, using our terms, we have the clients, which are the systems that are being backed up or recovered, your backup server, where your data is stored, and your administrator. That's the system that manages it all. So with our software, we've actually broken those out. You can set it up this way if you have a smaller environment. Your admin can also be your backup server, but you can also break it out. So you can have some clients writing to one backup server, some clients writing to maybe a different backup server, or you completely mix and match it for efficient use of your network or redundancy. Now, why would you necessarily want to do that? Well, if you have thousands of clients, obviously you don't want to write them all to one server. But what if some of these servers are on different network segments or different VLANs? And so if you're having to drag that data across a WAN, your performance, the backup performance, is going to be horrible. Whereas if you can stand up a backup server, let's say in that particular network segment, then those backups are going to run very, very quickly to the closest backup server that it can reach. And again, but simplicity-wise, you're managing everything from a single pane of glass. Now, scalability, where does that go? Well, that can actually take you into managing multiple data centers. So you can have a data center, let's say, in a different geographic location from another. The clients there are going to be backing up to their local backup server, so that way they have the closest point. But again, you're managing everything maybe from a completely different location. And this adds even a better feature, or one more feature here, is that since you can have multiple backup servers, why not stand up a backup server at your off-site location? So no more having to put things on a tape, on a truck, and shipping them out somewhere, or putting them on disks, USB drives and things, and then moving them off-site. If you could stand up a server sitting at the off-site location, and that could also be the cloud, you can back up your systems locally to the production backup server. Those backups can automatically get copied off. That's part of the scheduled job. They can be automatically copied off to the off-site location. And then in the event of a failure, you can immediately start recovering your systems at the off-site location because your backups are already sitting there and ready to go. And then if you have to do a production site recovery, you just reverse the process. You get the backups from the off-site location, you move them back over to production, and then you recover your production systems. Now, if you've ever had to do a production site recovery, our software, being able to restore to dissimilar hardware, is really critical there. Because think about your servers that you have, your physical servers that are sitting in your data center. What if you had to replace one that was, say, a couple of years old? It's not uncommon to have servers that are 1 or 2 years old. But if you went to your vendor and actually tried to buy that exact same server, you may not be able to, because disk sizes change, disk geometry changes, and even if it's the same model number, inside the controllers that they use may also have changed. And so any type of those type of changes will prevent that system from booting if you were doing a disk image. So again, it has to be exact same hardware if you're doing disk images, but with our ASR process, it doesn't have to be the same hardware, it doesn't have to be the same manufacturer, it doesn't even have to be physical or virtual, it doesn't matter. So enough talk, let's go ahead and see it in action. So today's demo, we're going to kind of install the software here, we're going to configure some clients and servers, we're going to create and run a backup job. That backup job is going to get copied off to a remote server, so I'll kind of show you what that looks like. And then we're going to go ahead and do a physical to virtual migration as well as a storage migration. Now we're going to boot this system up over the network. So we're going to create network boot media. And for today's demo, I've got a physical system. It's like an old desktop with a 16 gig drive in it. And we're going to restore that into a virtual machine with two smaller 6 gig drives. Okay, so we're going to have less space, different number of disks, and we're even going from physical to virtual. So there's going to be a lot of changes going on here. But we kind of want to show what is actually capable. So let's get started. Okay, so this is the web-based interface. Like I said, we have a graphical user interface where you can do most everything from the command line if you wanted to. Let's see here. Okay, so what I've done, I've installed the administrator software on hostname Padres. Now, I've also made Padres a client, and it's also one of my backup servers. So in that example where I showed all your clients writing to one backup server, this would be that kind of environment where you have your admin is also a backup server. But I'm going to add another backup server. I'm going to call it offsite server. That's the host name. Got real creative there. And so now you can see I actually have two systems that I could be, two servers I could be writing my backups to. One other type of backup server, which I did not mention yet, is NFS. So if I can also write to an NFS share or NetApp appliance if I wanted to. Okay, so now I've got 3 different locations that I could be writing my backups to. I'm writing them locally to Padres. I've got an offsite server here, and I've got my NFS server. Now you notice that little icon changed. That went from red to blue here. Notice that the little icons here, the little green icons, that's letting me know that I have network connectivity. So this is a real-time dashboard letting me know what is available right now. And the little icon, the little L here is letting me know this is a Linux system. I happen to choose an AIX system as my offsite server. Doesn't have to be, could be a Linux system, but I wanted to show how seamlessly we work between Linux and Unix. So that could either be a Solaris system or an AIX system. And so I also added Padres as a client because I'm going to want to back this system up from time to time as well. Now, the system that we're going to be backing up and we're going to do a clone of today is hostname Aztecs. So let's hop over here. And this is a terminal window of that system. This is Aztecs. It's a Red Hat Enterprise Linux 7.6 system. And I've downloaded the tar file from our website. So I'm going to go ahead and show you how easy it is to install. So I'm just going to untar it, and inside of there is st install script. Now there's a README in there that tells you this as well. So I'm just going to run this st install. Now the first thing it's asking me for is the licensing type. So it's probably a good time to go over what our licenses are. So we have a workstation edition. This would be a standalone box, not networked. So you're not writing to clients, and you don't have clients and servers and that sort of thing. This would be more like a standalone system that you would attach, let's say, a USB drive or a tape drive to. And this would be the case where you're a 99.9% Windows shop and you've only got one Linux system that you have to manage. That's where you would use Workstation Edition. Network Edition is what we've already described, where we have the admin, clients, and servers. And then we have a TSM or Tivoli Edition. or Spectrum Protect, as it's now called. IBM changed the name of it. And that's where if you want to write all your backups exclusively to a TSM server, if you integrated with that. In this particular case, now we've already installed the Network Edition on hostname Padres. I did that in advance. We're just going to install the agent portion on our client. So I'm going to go ahead and select C for client server. I'm going to put in the host name of my admin. This is for security purposes. Selecting all the defaults. And we're done. Now, the license I chose was client/server. What is that? Why would one be a client and be a server? So going back to this, I'm going to go ahead and, as you know, you have offsite server and Padres. Offsite server is a server only. So that same license I chose, client server, I just install the agent on this system and then specify that it's a backup server, and so now I can write to that system. So again, you only have one admin, and then you have systems that are designated as clients, systems you manage backups of, or servers, locations where you actually write the backups to. So let's go ahead and add Aztecs. Now there's a lot of options here. I'm not going to go over those right now. Just kind of hit the high points here. So we've added Aztecs as a client. So now I've got two clients I can manage the backups of. I can manage the backups of the administrator and of client Aztecs. Now we're also going to add one more client, and that's going to be our clone target today. So when we do our recovery, it's not actually I don't call it a recovery, I actually call it a clone, because we're going to be backing up Aztecs, and then we're going to restore it as a different host name and different IP address. So that way, at the end, we can do a side-by-side comparison of the two. Let's go ahead and add that host. And that's hostname Tritons. And you'll see on that indicator, the dashboard here, that one is in red because it's down. In fact, it's a virtual machine that's powered down right now. Okay. So as you can see, I've got Aztecs, Padres, Tritons. Again, remember I noticed that it was down, and that's because, it's a virtual machine that doesn't have anything on it. It's even powered down right now. But that will be our clone target. Now, I add that in advance because we're going to configure this Tritons to boot over the network. So that's why we want to go ahead and add it in now. Okay, now the next thing we would do is we would create our backup job or schedule our backup. But I want to add a couple of optional things here to this backup. The first one being an exclude list. Now, going back here, notice I talked about, VM snapshot, the snapshots versus the file-based ASR, and we were looking at this virtual machine. Well, what if I only wanted to back up the operating system and the applications, but I didn't want any of this user data? So how you would do that is you would just create an exclude list for this client. I would say, you know what, I want to exclude this data when backing up this client. So I'm just going to call it home. And I can make it apply to all of my clients or just particular clients if I wanted to. And I'm going to say, you know what, I don't want to back up the home directory. I just want the operating system part. Let's go ahead and save that. Another option I kind of want to talk briefly about is snapshots. Now, wait a minute, didn't I just say snapshots were bad? Well, I'm talking about a different kind of snapshot. The technology, the idea of a snapshot is freezing that system where the data doesn't change. The data is consistent. And so you can back it up in a consistent state. More to the point, I'm talking about how do you back up a database? Because you never want to back up a database, a relational database, while it's up and running. So what are your options? Well, you either don't back up the database using your backup product. You have to use something else like RMAN or some other tool. Or you shut down the database, so that way it's in a consistent state when you back it up, not preferred. Or you can create a snapshot logical volume of that. And so our software incorporates snapshot logical volumes in the product. So what we can do, and if I go to Aztecs, you can see here's all my logical volumes. And I happen to have a logical volume for my Oracle DB file system. Now, if you have Oracle, you know that's probably U02. U01. That's probably not what it's called, but hopefully you get the point here. So I have this logical volume, I have this Oracle DB file system. So I'm going to go ahead and select that, and I'm going to say, you know what, I want that to snapshot whenever I make a backup. So I'm going to be able to back up the entire operating system with the live running database, but that the database data will be consistent because we're going to create a snapshot at the logical volume level, and we're going to back up that. Now, it's still a file-based backup, so we're going to actually mount that up in a separate location and back up all the files, but they will be in a consistent state. They won't be changing. Okay, so now I think we're ready. We've added a couple of optional features here that we're going to use in our job. So let's go ahead and create our first backup job. So I'm going to call this my weekly backup. And where do I want to write it to? Well, I could write it to the NFS share, I could write it off-site, or I could write it to Padres, my local backup server. I'm going to go ahead and write it to Padres. What kind of backup do I want? That's the backup profile. And again, we're a backup product. So if you have other uses here, you want to back up directories on a regular basis or particular file systems. But the backup type that includes all of the information necessary to rebuild the system from scratch, that's going to be your full system backup profile. Now, we can also go in and customize that profile some and add some additional features such as compression. We can run our own scripts pre and post. We can even set this up as incremental level 0, so that way later we can do incrementals or differentials of our system. So we're not having to back up the entire thing. Let's say we can do a monthly full, a weekly, and maybe dailies. Okay, that gets into what's called RPO, recovery point objective. All right. And we can set a backup schedule here. So let's go ahead and run this on, let's say we're going to run it all months, all days of the month, and we're going to run it every Sunday at 1 a.m. And we're going to back up Aztecs. We can actually back up other clients as well, but for this purposes, we're just going to back up the one. But we can make a job where it backs up all of my systems as part of the same job. You don't have to have a separate job for every single client. And then we're going to write it over to our backup server. This is a directory that's over there. Now, the directories are just default directories that we had set up. You can actually change that to whatever you wanted. And we want to use an exclude list, so we're going to use our home exclude list we created. We didn't set up encryption right now, so we're not going to use the encryption feature. We do want to perform snapshots because we've already set that up. And we also want to copy that backup off to our offsite server as part of this job. Now, when do we want this copy to happen? We can say, well, immediately after the backup's complete. We could say maybe 2 hours later, or we could say today after 7 p.m. I'm going to go ahead and set this up as immediate. So as soon as this job is done, it will go ahead and copy it off to the remote server. And then as part of this weekly scheduled job, I'm going to have it create bootable media. Now, why do I need boot media? Well, you need boot media because, remember, what we're storing onto doesn't have an operating system. There's nothing there. So you boot it up and it just doesn't boot. It sits in BIOS or UEFI or whatever. It just posts. So you need to be able to boot from something. So our options for boot media, you can create a bootable ISO. You can create network boot media. So you boot over the network doing Pixie boot. Or you can do both at the time of the backup. So I'm going to go ahead and just create network boot media. I'm going to store that over on Padres because Padres is also going to be my boot server. So I'm going to actually be able to boot this system up over the network from my admin here and do a network boot and then a network recovery. So let's go ahead and save that. So now if I go in, I've got my jobs here. I could have lots of different jobs scheduled. So let's go ahead and start that job. Okay, so it's in our backup queue. I can go ahead and look at the status here and do a little play-by-play. Now, the first thing we're doing is we're creating that bootable media. So let me go in a little more in depth about that. Why don't we just supply you with a generic rescue disk? Well, because that generic rescue disk may not include all of the device support that's on that system. So A lot of people may not be aware of this, but all of the device support that Red Hat Enterprise Linux 7.6, in this particular case, supports is going to be on the system itself. Now, you may not be aware of that, and the reason why your disk images don't work is because what has been configured to be used. All right, so and that's getting a little bit in the weeds here, but that's in your init ramfs. So the init ramfs says what drivers or modules need to get loaded for the particular hardware that you're sitting on. However, all the drivers for all of the hardware is still on the system. It's just hidden away. So what we do is we actually, when we create this bootable media, we grab every one of those drivers, all of those modules, and we put it on our boot media. So that way, when we go to do our recovery, we'll actually do device detection, load up the drivers that are needed for that hardware, and then at the end of the process, we'll make the system bootable using the new drivers. That's the magic behind being able to do dissimilar hardware. Okay, so we've created our bootable image, copied that over, made our file list here, verified that we were going to be able to do our snapshot. Notice here, we've got a note here. It says file system home was excluded from the backup. Remember, we set that up. And it's going to take a couple of minutes here to run this backup. So now we've already created our boot media. So while this is finishing up, let's go ahead and configure our client to boot over the network. Be efficient in our time here. Now, if you've ever set up a Kickstart server or NIM or Jumpstart, you're going to be pleasantly surprised to see how easy this is to, configure a system to boot over the network. Setting up the Pixie config files and all that is all done within our product. So the client that we're going to be restoring, we're backing up Aztecs, but we're actually going to restore Tritons. That's the client that we actually want to boot. Now we select our boot server. Again, any server that's out there can be configured as not only a backup server, but also a boot server. So we're going to boot from Padres. We're going to select the boot image. That's the one we just created. Put in some network information. Now it's asking for the MAC address. Now, when you're booting Linux boots using Pixie, and Pixie is a broadcast protocol. So it does need to have the MAC address that you plan to use to boot up. Well, how do I get that? Well, I'm actually going to go back over here to my virtual machine. And I can go down here to my network information. There's my MAC address. I'll copy that. There we go. And then I can also go in and set some defaults as to, which server I want to do my recovery from. I can even go and select the backup and do a no prompt install. Now, a no prompt wouldn't work in this case because we're not going to be able to restore this system as is. You remember, we've got disks that are smaller. It's spread across 2 disks. This is not going to fit the way it's set up now. The way it's been backed up is not going to be able to be recovered exactly the way it was. And we're doing this on purpose so that way you can actually see, well, how easy it is for me to change the storage configuration so I can fit onto most anything. So that's enough for right now. I'm going to go ahead and just enable that client for network boot. And there we go. So all those Pixie configuration files and all that have already been created. It's ready to go. So let's go in here and look at our, so our backup is already completed. Now we're in our copy. So now we're copying from one server to another. So we're copying this over to offsite server. All right, so we've done our copy is going on right now. Our backup completed successfully. So let's go over here to this virtual machine and boot it up. So let's check our boot options here. Yep, set to boot off the network adapter. Hopefully I don't forget to change that back. All right, now the first thing the software is going to do is device detection. It's going to go in and determine, okay, what drivers need to be loaded. So remember, we had all the device support on there. So now it's actually loading the different drivers. Okay, this is the only blue screen you ever want to see. This is the Storix System Installation and Maintenance menu. Let me see if I can enlarge this slightly. No, I don't think so. Okay, so this is what you would see whether you boot over the network or you boot from an ISO. And this will work whether you're on serial terminals, you know, old dumb terminals, or you're going through VMs, or however you want to connect to it. You connect into the system, this is what you would see. Now, we've already selected the server that we're getting it from, but we didn't select the backup. But I kind of want to go through this real quick just to show you our options. So we could be restoring from a local tape drive, a local disk, like a USB attached drive. We could be getting the backup from an NFS share somewhere, a remote system with a tape drive or tape library attached, or a remote system that was written to disk. And so that's what we did in this case. So let's go ahead and select that. There's the directory we wrote it to. And there's our weekly backup that we just wrote. Now, if we were doing a straight recovery, we would just say install the system with current settings, and we'd be done. However, the software is going to tell you whether it's going to work or not. And believe it or not, that's actually really important, because a lot of products out there will let you they'll give you the bullets and let you shoot yourself if you want to, meaning, you know, it won't tell you, you know what, this isn't going to work, and you're going to need to make some changes first. And so our software is going to help walk you through that. So right now it's letting me know that one or more disks are not large enough, which we kind of anticipate. So I want to go in here, and I want to make some changes. So I can look at the disks that we had. Now, this table here, the first column says backup data. It was originally SDA. It was one disk, roughly 16 gigs in size. And then if you look at the fifth column over, it says current disk, SDA and SDB, and they're both about 6 gigs in size. Okay. Now, the partition table that we were going to write was going to be for a 16 gig disk. Well, that's not going to fit on a 6 gig disk. So what do we do? Well, we can go in and we can change the partition table. I've got 2 partitions on this one. I've got a boot, and then I've got another one that is our physical volume for our volume group. Now, if you also look down at the bottom, it says free megabytes, and it's a negative number. That's because we've over-allocated on this partition. So, well, how do we fix that? Do we go to some config file or text file and make changes? No. We easily just go in here, change the partition information, and I can go in here and just set that. There. So now the partition is going to fit on this smaller disk. However, but it's only a 6 gig disk. What about all the other data that I need? Well, I can go into my logical volume management, and I can add that second disk as a physical volume. Then I can go in and add it to my volume group. There. So now I'm using the storage of both disks. But let's say that wasn't enough. What if I needed to go in and make further changes? Now, I might have file systems, you oftentimes see this, where there'll be a file system created, and it was created way too big than what you needed. So, well, what I can do is I can kind of steal from Peter to pay Paul. I can go in and reduce the size of the file system that's going to get created, so that way I can free that up and add that space somewhere else. So I'm going to go in here. Now, home was actually excluded from the backup, but I'm going to go ahead and reduce the size of this to 256. Okay, now that's size and min size. So min size is how big it needs to be. So I can always reduce any of these down to close to their min size. Now, if I reduce it down to exactly the min size, well, I'm at 100%. You don't really want to do that. But I can definitely reduce them down to make it fit. But what if I have the opposite problem? What if I know, hey, I'm already here anyway, and what if I have a file system that's already starting to run out of space, and I've got some extra space? Maybe I'm restoring onto bigger disks. Well, I can go in here and do the opposite. I can go ahead and increase the size of the file system. There we go. You can even go in there and look at our file systems. You can see I've got root, boot, home, my Oracle DB file system, user, var. Notice that root, for whatever reason, was installed as ext3 when everything else was XFS. Well, we like to be consistent, so let me go in and change that. I've got to rebuild it anyway, so why don't we just rebuild it as XFS? There we go. Now, one other thing I wanted to do, I forgot to do here, is I wanted to specify what logical volumes to use here. Now, right now it's specifying to use SDA, but I've got this extra disk, so I'm going to add that one to use the other disk. And we'll do a swap too. Make swap go to the other disk as well. Fair enough. All right, now in all the options I could make, I could change partition tables, I could add partitions, do pretty much anything I want to with the logical volume management. I could create volume groups, new logical volumes, and so forth. Metadis or RAID, software RAID, so I could work with software RAID, I could create some software RAID devices if I wanted to, add or change file systems, and so forth. So there's pretty much anything you could do, you would normally do in an installer. You could actually do that with our software, but you're doing it with a backup. So whenever it comes time to recover, you don't have to worry about, do I have enough space? Am I going to be able to make this work? You know, because you're going to be in a panic at that moment. If it's a true system, you know, that's down, you're trying to get that system up as quickly as possible. That's that RTO we were talking about. You're going to not want to worry about, you know, is this going to work or not? You want to make sure that it's going to work. Okay, so just to kind of recap what we've done here, we backed up a physical system and we're restoring it into a VM. We went from one larger disk to two smaller disks. We've decreased the size of one file system, increased the size of another file system, and even changed the file system type in the process. So there's a lot more we could do with this, but hopefully that gives you an idea of, you know, how flexible this software really is. So now when we say install the system with current settings, hey, no problems were found now. And now it allows me to go ahead and continue. So the first thing the software is doing is creating the partition table. Now, we actually, again, unlike a disk image, we're just going to DD everything back onto the new disk. We actually go in and rebuild the system. That's what gave us the flexibility of making changes. So we remade the partition tables, remade the logical volumes, remade the file systems and mounted them up. And now we're restoring the data back on top. Now, it looks like this is only going to take a minute or so to recover everything, so it's probably a good time to hop back over here. And let's talk a little bit about support. So, obviously, we have documentation, but the reason why I want to bring this up, we have obviously our user guides. We've got system recovery guides, which are geared for each OS, because if you're doing a system recovery of AIX, its terminology is a little different than maybe Solaris or Linux. You're talking slices versus partitions and so forth. But really what I want to focus on is we've got a quick start guide. Grab that first. You know, you don't need to dive into, you know, pages upon pages of documentation. Our quick start guide is only a couple of pages. It's going to get you up and running very quickly, get you up and making your first backup in a matter of minutes. And it covers most everything we did today in the demo. We have an online help desk where you can create and respond to your tickets on your time 24/7. And we're going to answer those tickets on our time during our normal phone support hours, which is 7 a.m. to 5 p.m. Pacific time. Now, notice that our host names today were Aztecs, Padres, Tritons. We used to have the Chargers. We're a San Diego-based company. And so all of our support and development is done here on the same campus in San Diego. So it is US-based phone support. And that's included with the software. So it's not like you get 2 phone incidences a year and so forth. No, this is included in the price of the software and maintenance. So you do get phone support. You actually call us and somebody actually answers the phone at our offices here in San Diego. And then we also offer emergency disaster recovery support. Again, this is also included. So if you have a system that's down, you're doing a system recovery, we have somebody who's on call 24/7 to assist you in the event that you've got a production system that's down and you're trying to get it back up. Doesn't matter if it's 2 a.m. on Christmas Day, not a problem. We have somebody who's on call who's going to help you with that. And again, this is all included. So this is not, added upcharges along the way. All right, so let's go back over here and see our recovery. Looks like it's just finishing up. And then we'll do a little side-by-side comparison. All right, so it's completed. Let's go type exit. Oh, before I do that, actually, let me type exit. I always got to remember to do this. Remove the network adapter here from the boot. There we go. Now it's going to boot from the disks. Now you might notice that we've got a new stanza in the grub menu. We didn't change out the kernel. We're still using the same kernel, but we did create a new initramfs. Now that goes back to loading the right drivers for the new hardware. So now that we've recovered onto dissimilar hardware and we are loading different drivers, we created a new initramfs. So that's what ensures that it's going to make sure and boot, because we're going to be loading the drivers that were detected when we booted up from our boot media. So as you can see, the system's ready. I'm going to go ahead and log in. There. Let me go ahead and pull this over here. Hopefully we can see both of those. Okay, so in blue is Aztecs. That's the system that we backed up. And then there's our virtual machine Tritons. That's the system that we recovered. That's our clone. Oh. Okay, so the first thing you want to look at here, let's just look at our file systems here. They're all there. There's our root, user, boot, home, Oracle DB. But notice that the size is down different. So remember, we went in and reduced the size of home. So home was 4 gigs in size, but now home is roughly 256 megs. Remember, we reduced that one. Then we took, I believe it was user, which was 2 gigs, and user is now 3 gigs. So that increased there. And we do the mount command here. You can see that root was on ext3. And now it's on XFS. Oh, by the way, one thing I did kind of gloss over. Wait a minute. If we restored this, how come it didn't come up as Aztecs? How did it come up as Tritons? Well, because the software recognized that we were restoring this system as a different IP address and host name as from the backup. So the software had the intelligence to go in and update the network settings. So if I wanted to use this as a provisioning tool, I could actually repeat this process over and over and over and over and over again using, let's say, Aztecs as my golden image, and I could just, partition out a complete data center if I wanted to. And then just to make sure that it's not just smoke and mirrors, let's go in here and do MIDE code. There we go. And this is there we go. It's a Dell Vostro 200. Like I said, it's an old desktop here, an old Dell that we did this backup from. And if I do the same thing over here, this is using Red Hat KVM on this system. Okay. So hopefully this gave you an opportunity to look at our software, see what it's capable of, and then hopefully maybe get you to thinking about how could you utilize this in your environment. What are ways in which this is going to help your job, not only protect your systems and getting it back up, but also maybe even using it as a way to either provision your systems, do some of those legacy migrations from physical to virtual, and so forth. So I want to thank you very much for watching our webinar, and have a good rest of your day.